All right, welcome. This is a second semester. We're going to start with trig. Trigonometry is looking at this idea of what do you know about a triangle? Let's start. What do you know about a triangle that if this is 90 and this is 50, what would this angle here be? Turn to your neighbor and tell them what you think. So one thing we know is that all the angles add up to 180. Now, another thing that we know is that if this were a 3, this were a right angle, and this were a 5, what would this one be? Why do you say that? Yeah, it would be a 4. Why is it a 4? Yeah.
It's the square of the square plus square.
Yeah, 3 squared plus x squared equals 5 squared, and so x squared is 25 minus 9. X squared is 16. What would x have to be a real triangle? 4, yeah. And we know this as the popular 3, 4, 5. So if you have two sides, you can find the third angle. If you had two angles, you can find the third angle, right? But what if you didn't know those? What if you knew a side and an angle? So you knew this is a right angle, you knew this was 30, and then you knew this was 8. Could you find this or this? How? Oh, yeah, for the sine and cosine. And that's what we're getting at today. If you knew two things, and actually here you could find this third angle, but you still only have one side. How would you get these other sides? So that's what we're going to do next, is we're going to find how to relate those two. So let's do this first. Would you look at this triangle here? Here's an angle theta, and it's just a regular angle. And then what we're going to do next, what we're going to do next is I'm going to draw a circle, and I'm going to make this circle a special radius, the easiest radius of them all. You know what it is? Don't say 0. 1, yeah. 0 would be a circle, would it? But 1 is the easiest. So this is called a unit circle because the radius is equal to 1. And since the radius is equal to 1, things get kind of nice. And we're going to make a point here, x comma y, and they like to describe the x as the cosine of angle theta and y as the sine of angle theta. It's just the definition of xy. So xy, they say this is cosine and this is sine. They're just calling it that. Now, if this is theta, this is cosine, this is 1, and this is sine, this triangle here is interesting because if they both are 90-degree angles and this theta equals this theta, what does these two angles have to do? Let's say angle beta here. What do these two angles have to be? If these two are equal and those two are equal, the betas also have to be equal. So we say these triangles are similar. And I like to bring in a little geometry because the more you tie concepts in, the more math makes sense. So if they're similar, we make this bold statement that one ratio equals the other. If you remember from geometry, one ratio of two triangles, like, for example, sine theta, the opposite, straight across from theta, over 1, is going to be equal to, okay, what's opposite this theta at the top? A. And then 1 is the hypotenuse. So what's the hypotenuse of this green triangle? C. So sine theta is going to be the opposite over the hypotenuse. Opposite over hypotenuse. Or I like to call it A over C, using that triangle. You try the cosine of theta over 1. See if you can do that. Did you get for that cosine over 1? Did you get cosine is it's not the hypotenuse. What did we call this when it's next to? Do anybody remember that? Oh yeah, adjacent. This is going to be cosine is the adjacent, which is b, over 1, which is the hypotenuse c. So this is the adjacent over the hypotenuse, which is c. And I'm just going to call this b over c. And then the last one, tangent, is the skimmer. Skims the edge of this triangle like that. And by definition, the tangent, and we'll actually prove this later, sine of theta over the cosine of theta. Okay? Sine of theta over the cosine of theta. So the sine of theta, let's see, I gotta write this out. Sine of theta, which was a over c, and the cosine of theta was b over c. What's going to cancel out? The c's. And so that'll leave you with a over b. A over b. Or a over b. A over b is the same as opposite over adjacent. Now you remember the shortcut version of this. You remember the shortcut version of this by sine being the what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. What was this short mnemonic device? Yeah, TOA. The reason I wanted to show this to you is I could have given you SOHCAHTOA and said it's a way to relate sides and angles when you don't have enough. But isn't it much more helpful to know where these came from? You don't have to do this on a test. But I just want to show you, and I will continue to show you, where these formulas come from, so you never have to ask, where did that formula come from? Because I'll always tell you. But again, tangent is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Feeling a little better about that? Now you get to see where it comes from. Well, let's do some special triangles now. Special triangles, if this is 45, if this is 45, and this is a square root of 2. Any ideas on what these two could be? You can just shout it out if you know. How do you say that? Pythagorean theorem. These two angles are the same, so these two sides are the same. So this is going to be 1 plus 1 is 2, square root is square root of 2. So that's perfect. Now this one looks a little more cryptic, but it's actually kind of okay. 30, 60, 90. Let's take this and reflect it so that it's the same triangle, just a reflection of it, like in a pool. And so this is 60, 60, this is 60. What can you tell me about all these angles? They're the same, so what can you tell me about all of the sides? Also the same. So if this is split in half, what will this length be? That'll be 1, yep. So that's weird. This is 2, 1. What's this height? Well, we can figure that height out by using Pythagorean theorem. The Pythagorean theorem is 2 squared will be equal to 1 squared plus, let's call this h, the height squared. So 4 is equal to 1 plus h squared. H squared is going to be 3, so what's h going to be? Square root of 3, and you are right, it is the square root of 3. So with these special triangles, we can set up the sine, cosine, and tangent for these special angles. And so for 30, 45, and 60, you're going to complete what we call an exact value chart. And I'm going to give you a little help, is that this is 60, and this, or 30, this will be 60. This length is 1, so the short side, this is 1, the short side will be a half. And then if you use Pythagorean theorem, it will be 1 minus a fourth is 3/4. Square root is 3/2. Likewise, if this is 60 and this is 30, the short side will still be a half, and the longer side will be square root of 3/2. And then with this one, these will both be 45, so x squared plus x squared has to equal 1. Well, 2x squared equals 1. X squared is 1/2. What's x going to be equal to? 1 over what? Square root of 2? Both of those are 1 over square root of 2. So those are my special triangles. And what you're going to do is you're going to use SOHCAHTOA to fill out these different rows using these triangles. And I think you can do it. Good luck. Some of you are making great progress on this. The sine of 30 is the opposite over hypotenuse, or 1/2 over 1. So that's just going to be 1/2. For the cosine, it's going to be the square root of 3/2 over 1, or the square root of 3/2. And then for tangent, it's going to be opposite over adjacent. That's just going to be 1/2 divided by square root of 3/2. What cancels out? The 2's. So this will be 1 over the square root of 3. How many got all 3 of those? Right. Any questions on that? You try the next 2. So for 45, the opposite is 1 over the square root of 2 over 1, which is just 1 over square root of 2. And the cosine will be the exact same thing. What's great is when you go 1 over square root of 2 and divide by 1 over square root of 2, what are you going to get equal to? What did you get for the tangent? Opposite over adjacent. 1 over root of 2 over 1 over 2. Isn't that just 1? You're done. Great. And then the last one is going to be a reverse. For 60, it's going to be square root of 3/2. For the cosine of 60, it's 1/2 over 1. And then for the other one, it's square root of, it's square root of 3/2, which is opposite, over adjacent, which is 1/2. The 2's cancel, and you'll just get the square root of 3. So the tangent of 60 is the square root of 3. Exact value means there's no decimals with a calculator. You don't need a calculator for that. All right, next thing. This is what I call a thinker. And I'm not going to spend any time on it, but I'd like you to think about it. Is there a way for you to find this theta and y? What's theta and y? If you like a puzzle, you like to challenge yourself, great question. Think about it. What is theta and why are you able to do what you did to find it? It's a great question. I'm going to move down to the homework and tell you what your homework is. You're going to complete each of these triangles. So here's a angle ABC, side ABC. Notice angle A and side A are across from each other. Angle C and side C are across from each other. So you use that to fill in these triangles, and then you're going to find side B, side C, angle A. Okay? And so, and then you'll have 1, 2, 3, 4 of those to do after. And then we've got some thinker problems to do. 2A, C, and E. Great problems. I'm going to go back to this number 5. Let's do this one together. What can you tell me? I'm going to make this a little bigger. What can you tell me just by looking at this that I can figure out real easily? What can I figure out? Angle A. Yeah. What is angle A going to be? 60. You got it, because they have to add up to what? 180. As long as this is 90, so 180 minus 90 is 90, minus 30 is 60. Great. Okay. Now, to find B or find C, can you just use Pythagorean theorem? I wish, but you can't. So let's try this. Let's try the sine of 60. Okay. Sine is SOHCAHTOA. Okay. So the sine is the opposite, 2.3, over B. I like it. Now let's trade places here. Let's put the B here. Let's put the B here and the sine of 60 down below. And we can just use our calculator for this one. So I'm going to grab my calculator. And I'm going to just do a quick little double check. Double check here. Is your mode, it's kind of hard to see here, is your mode degree? Make sure it's in degree. And then you just take 2.3 divided by sine of 60, and you should get 2.6558, or 2.7. We can say it's 2.7. 655, we'll say 2.7. Round it to the nearest tenth. So there's your 2.7. Now, how are you going to find C? Turn to your neighbor, tell them how you're going to find C. Many ways to solve. So someone said that the cosine of 60 is C over 2.7. So if I multiply 2.7 times the cosine of 60, I'm going to get C. And that's going to be, well, I know this is half, so I can do this in my head. It's going to be about 1.35 centimeters. It's going to be your C. And that fills out the triangle. You've got all the lengths, ABC, all the angles, ABC, and then you've solved it. So go ahead and do that for all the rest of those triangles. So 2A has three triangles actually, and this particular triangle has an angle of 30, length x. We don't know the opposite. This other one has a length x. We don't know the opposite. But we do know that these two angles are 60. What will this angle have to be? Have to be. 60, 60, what does this have to be? You got it. So write that in, 60. Now they're saying that this is 2 across here. What can you say that this length is? Yeah, because they're all going to be 2, aren't they? All right. Now you figure out, knowing this triangle has an angle of 30, and you know this is 2, and you know this is x. Can you find out what x is? See if you can figure that out. And then that wraps up the assignment. Notice we have some just figuring out skills of filling out a triangle, but then 2A, C, and E are applications, which is where I want you to be. And this wraps up my intro to Trig. The answers are on Schoology on PDF.